Hi, so this is module 8.2 in unit 8, and we are going to be learning about area of triangles today. Our learning target, I can understand how a parallelogram can be decomposed into two congruent triangles to find the area of one triangle and use the area formula for a triangle to find areas or missing dimensions. So the vocabulary that we will be learning is base, congruent figures, and the height of a triangle. So before we go on into the lesson, I just want to take a moment to refresh your past learning about the different kinds of triangles. So I'm going to take you to my whiteboard for this so that we can just look at the different types of triangles. Okay, so the first kind of a triangle is an equilateral triangle. And in an equilateral triangle, as you can see over here, okay, all the angles, all the sides are congruent. We're going to talk about what does congruent mean, that they have exactly the same measure, all right? Now, all the sides and all the angles have exactly the same measure, and so therefore you have three congruent sides and three congruent angles, and each angle is 60 degrees. They equal 180 degrees. So in every triangle we have 180 degrees. Okay, then we have an isosceles triangle over here, and so you have two congruent angles and two congruent sides in an isosceles triangle. All right, let's look at another one really quick. And here we go. We have a scalene triangle. There is no congruent side, no congruent angle. Everything is different, and that is a scalene triangle. Then if I look at a right triangle, it has 190-degree angle. Okay, so a right triangle has 190-degree angle, as you can see over here. All right. Here we have an acute triangle. It has three acute angles. That means they measure less than 90 degrees. So you have 61, 82, 37, etc. Okay, all of the angles over here you can see they are measuring less than 90 degrees. So that's an acute triangle. An obtuse triangle will have one of the angles which is greater than 90 degrees. So one angle will be greater than 90 degrees. Okay, the others will obviously be acute. Otherwise, how will that triangle close? All right. So now let's quickly talk about, so that was just a refresher about the different types of your triangles, but now we're getting into finding the area of a triangle. So let's look at what is a congruent figure. Okay, a congruent figure or congruent figures are figures that have the same shape and size. So if I have a parallelogram drawn out, okay, if I have a parallelogram, I can decompose it or break it apart into two triangles which are absolutely congruent. Okay, and so I need to understand that in a quadrilateral, when I break a quadrilateral, which is whether it's a square, it's a rectangle, whether it is a parallelogram, and I put a line down, okay, like this, for example, I end up getting two triangles in a quadrilateral. And in a quadrilateral, I know that I have either length times width or I have base times height. So basically, what am I doing? I am just taking any quadrilateral. So let's say I have a square, for example, and we know that we have side times side for that, right? Or if I have a rectangle, it is length times width. So we have this. So now look what happens when I do this. What did I end up with? Two congruent triangles. So instead of saying length times width, in this case, what am I saying? I'm saying base times the straight line that goes up and down is my height, right? And that is what a parallelogram area was, and we just learned that lesson in module 8.1. So when I have two of them, so instead of saying base times height, look how many triangles I have in there. That is 2. So that is why each of these is what? 1/2 base times height. Each triangle is half the base times height, which is the area of a parallelogram. So you can say 1/2 base times height, or you can say base times height divided by 2. So both of these tells you that that is the formula of a triangle. So if I look at this one, okay, if I look at this one and I'm looking at, okay, what is the area of this parallelogram? And we've learned that the area of a parallelogram is base times height, right? So if I'm looking at 1, 2, 3, 4, 5, 6, 7, 8. So this entire thing is my base. And then I'm looking at the height. So it's going to be, remember, height is this line which goes straight up and down. So if I just take this as my height, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So what is the area of the parallelogram? Is the base times height, which is what? My base is 8, my height is 12. So my area is 8 times 12, which is the height. And so this gives me 96 square units. Okay, 96 square units. Okay, now when I'm looking at this, that is my parallelogram. But what do I see within the parallelogram? I am looking at the parallelogram and I have two triangles. So you see, if I look at this one, I break it apart, see? If I just cut a line across, I have two congruent triangles. I can make the other triangle with a different color so you can see. Here you go. This is one and this is the other triangle. And that is why we do base times height divided by 2, or a triangle is 1/2 the area of a parallelogram, which is 1/2 base times height. So if I do 96 over here, okay, this whole thing is 96. So if I'm going to divide 96 by 2, it's going to give me the area of one of these triangles, which is 48. So this is 48 and this is 48 square units. Okay? And that is how you calculate the area of a triangle and why it is half the area of a quadrilateral. Let's look at this one. So we're trying to find the area of this triangle. Okay? Now, when I'm looking at this, really quick, what do I see? I have an example over here given to me, and I'm trying to find, I've got the base given to me, I have the height provided to me. Okay, so we know what is the area of a triangle. We just said that it is half base times height. Okay, so it is going to be 1/2 base times height is the area of a triangle. Always write out the formula, because a formula is an equation and then you know what values to substitute based on what is provided to you. So let's look at this. This is my base and this is my height. Okay, again in a triangle, please remember it's got to be straight up and down vertically for it to be the height. Okay, please don't count this as the height ever, because that is a slope. That's the hypotenuse. Okay, and so we have the base given to us as 6. So I'm going to substitute the values. 1/2 times 6 times my height, which is 4. And so this is literally saying over 1 over 1. And then I know that I can simplify before I multiply. And so 1 times 2 is 2 and 3 times 2 is 6. So my area now is what? 3 times 4. And that gives me 12 square centimeters, or centimeters squared. And that is the area of this triangle. Area of the triangle is 12 square centimeters. So let's do another problem quick. And let's look at this one. Finding the area of this triangle. Once again, the base and height are given. So the area of the triangle is 1/2 base times height. Okay, my base is given to me as 5. So area is 1/2 times 5 times my height, which is 2. And then once again, I can simplify anything from the numerator to the denominator. And so 2 divided by 2 gives me 1. And area is equal to 5 square feet. And there is my answer. All right. Now, let's look at another example. And we'll do this one here. And I'm going to use this color. Okay. The front of a camping tent has the dimensions shown. So this is the front. And how much material was used to make the front of the tent? So when I'm talking about that, basically I'm trying to find the area of this. Okay? So I have the triangle. This is my triangle. Okay, once again, we never look at this for the height. We always look at the straight up and down line. Remember what I said, when you go to the doctor, you don't stand like this for your height. You stand straight up and down. Okay, so that's how the height is calculated. So now let's look at area. Area is equal to 1/2 base times height. So therefore area is equal to 1/2. What is my base? Is 5 1/5. So times 5 1/5 times my height, which is 3 1/2. Remember, when we are multiplying fractions and mixed numbers, you have got to convert it to an improper fraction first. So don't try to do 5 times 3 and all that mess, okay? So we've got to convert it to an improper fraction. So area is equal to 1/2 times. To convert a mixed number to an improper fraction, once again, you multiply the denominator with the whole number part. So 5 times 5 is 25 plus the 1, which is 26/5 times 3 times 2 is 6 plus 1, which is 7/2. Okay? And now what we can do is we can simplify before we multiply. And I get 1 times 2 is 2. And 13 times 2 is going to give me 36. And I don't have anything else that I can simplify over here. So then if I look at what is 13 times 7, what is 7 times 3? That gives me 21. 7 times 1 is 7 plus 2, which is 91. So therefore, I get over here, area is 91 over 2 times 5 is 10. And that gives me back to a mixed number. I'm going to get 9 1/10 square feet. And so this is my answer. 9 1/10 square feet. Okay? Now, let's do one where there are sometimes missing dimensions. So, let's go ahead and do this one. Find the missing dimension of the triangle. All right, I'm going to find the missing dimension of the triangle. So, let's look at what are we missing. And if I am, again, I know that I'm trying to find the area. And the area is already given to me. And the height is given to me. So what am I missing? I'm missing the base. And that's what I need to calculate now. So once again, please remember, a formula is an equation. So I am just going to write it out. A is equal to 1/2 base times height. And is my base given? No, it isn't. Is area given? Yes, it is. So I have 24 and 8/10 is equal to, so I'm just substituting the value, look. It told me that area is 24 and 8/10. So I just plugged in that value. I substituted that value for A is equal to 1/2. I don't know what the base is, and I know that the height is this. This is my height, is 6 and 2/10. Okay, now once again, before I do any other calculation, I can easily simplify, and I can do 1 times 2 is 2, and I have 3 times 2 is 6, and I have 2 divided by 2 is 1, so I get 3 and 1/10. So now I have 24 and 8/10 is equal to B times 3 and 1/10, which is 3 and 1/10 B. So now this is a one-step equation, and I know that when I have the coefficient before the variable, that means it's multiplication. So what is the inverse of multiplication? I'm going to use the division property of equality. And so I am going to divide both sides by 3 and 1/10. 3 and 1/10. Okay, and so 3 and 1/10 divided by 3 and 1/10, I am going to get 1. And so my base is equal to, then I'm going to divide 24 and 8/10 by 3 and 1/10, and I am going to get 8. When I divide 24 and 8/10 by 3 and 1/10, I end up with my base as 8 centimeters. And so that's how I find the missing dimensions. All right? Now, so that's basically what this entire lesson is about, just trying to find the area of a triangle. Please remember that in a quadrilateral, I have 2 triangles, and so that is why if I have a parallelogram and I have said that the area of a parallelogram is base times height, so since there are 2 triangles within that parallelogram, I'm doing the base times height divided by 2. Or since there are 2 triangles in there, a triangle is nothing but half the area of the parallelogram, which is half base times height. And that's what area of triangles is all about. Have a great day, everyone.